Hello and good evening to everyone. Welcome back to another lecture on the Resultant AG YouTube channel, and welcome to this mixed question practice series where I will be taking the questions from the different subjects of mechanical engineering for RRB JE 2024 exam. So good evening everyone. Welcome to this session. All the RRB JE aspirants who are going to write their RRB JE 2024 exam. Firstly, obviously CBT1, which will be non-tech, and then after qualifying the CBT1, those who will be qualifying it have to perform really well in the CBT2, which is technical and non-technical combined. So for that, basically, we can say that if anyone is thinking, sir, firstly we need to first qualify CBT1, then we'll go for CBT2, then I must tell you, firstly, you should be ready with both the steps, because CBT1 is qualifying in nature. If you get around 100 out of 60 marks also, then also you will be qualified for CBT2. But if you don't prepare for CBT2 well in advance, then your selection will be, will not be there, right? So I want all of you to prepare for CBT2 well in advance, whether it is RRB JE, and those who want to prepare for SSC JE CBT2, then you can follow our session. Hi Sagar Kumar, good evening, welcome to the session. So let's begin everyone. I hope everyone is doing fine, and let's start today's session. Let's begin. So my dear students, I also want to tell you that if you have not yet subscribed to Resultant AG YouTube channel, then please do that. Take out few seconds to subscribe the channel and also press the bell icon so that you never miss any videos from our YouTube channel, whether it is technical videos, non-technical videos, any kind of shorts, or any important exam notification. Also, my dear students, if you have joined this session, then please take out few seconds to like it and also share it in the telegrams where you can find the like-minded students who are preparing for RRB JE or SSC JE or any kind of technical exam. Then you can share this session. If I have to give my quick introduction to all of you, I am Vikas Sir. I am a faculty of mechanical engineering, and I have been teaching from the last 7+ years. This is my total experience, and I have taught these subjects so far: fluid mechanics and thermodynamics, applied thermodynamics. Hello Ramjeevan, good evening. I have done my MTech in thermal engineering from Thapar University and mentored more than 1 lakh students for these exams. Okay. Let's come to question number 1. I will not be wasting your time, neither mine. Which component of the vapor compression cycle is where refrigerant absorbs the heat and evaporates, providing the desired cooling effect? Hello Subbu, good evening, welcome to the session. What will be the name of this component where the refrigerant absorbs the heat? So if you see the vapor compression cycle or vapor compression system, in the vapor compression system, there are different components which are arranged like this. Okay, so there are different components working in a cycle, and their main purpose is to produce the cooling effect. And in this cycle, there are different components. In these components, the refrigerant will be moving like this. Okay. It will go from compressor to condenser. From condenser, it will go into throttling device. Okay. And then from throttling device, it will go into evaporator where it will perform the cooling function. So evaporator is that function component where the refrigerant, when the refrigerant will come into the evaporator, then here the refrigerant will absorb the heat and change into vapor after absorbing the heat and produce the cooling effect. So main cooling effect here, the cooling effect is obtained in the evaporator. Okay, so the right answer will be option A. Very good. Sagar Ramjeevan Kumar. For maximum work done, what will be the values of efficiency and exit temperature after the expansion stroke for Otto cycle if the maximum and minimum temperature are limited to 1400 degrees Celsius and 300 degrees Celsius? That means for the Otto cycle, the minimum temperature, so please share this PDF or PPT in the channel. Okay. Yeah, I'm also thinking the same, that from today onwards, I will because I told you that it's not possible to convert PPT into PDF in my laptop. So what I am going to do is I will share the PPT. I will start sharing the PPT with you guys. Okay. So I will share you the PPTs of my YouTube channel, and you can just study from there. Minimum temperature is 300 degrees Celsius. The maximum temperature is equal to 1400 degrees Celsius. Okay, in the Otto cycle. And they are saying that for maximum work done condition in the Otto cycle, when the work output is maximum in the Otto cycle, is maximum 1, 2, 3, 4. Okay. So for maximum work output in the Otto cycle, hello, good evening, Akshay and MS, good evening. Maximum work output, the T2 and T4 becomes geometric mean of T1 and T3, where T1 is the minimum temperature and T3 is the maximum temperature of the Otto cycle. So what are they asking in this question? Value of efficiency and exit temperature after expansion. That is, they are asking T4 and efficiency of the Otto cycle. So how you will find T4? T4 will be equal to geometric mean of 300. Okay, this is degree Celsius. Firstly, you need to convert into Kelvin. Okay. Find it in Kelvin, you will get 300. Yes, come on everyone, try to solve it. It's a very simple calculation. Okay, so this is 573 Kelvin. This is 1673 Kelvin. Okay, now put this value 573 into 1673. You will get T4 is equal to how much? Okay, you will get 979.09 Kelvin. Okay, so an answer will be either A or it will be D. So B and C will not be the answer. Next thing is efficiency. Efficiency of the Otto cycle, we all know it is 1 minus 1 by compression ratio power gamma S1. But you can also write efficiency as 1 minus T1 by T2. In this question, you know that this is T4 and T4 is also equal to T2. Okay, so efficiency of the Otto cycle will be equal to 1 minus T1 is 573 Kelvin divided by 979.1. Okay, just solve it, you will get the efficiency. Tell me everyone, what is the answer you are getting for this question? 573 divided by 979.1. Okay, so you will get 42%, 42% approx efficiency. The right answer will be option A for this question. Okay, clear? So that's a simple calculation. I hope all of you have understood this. And I have also something to tell all of you, that I have seen you guys that yesterday the session was not over, and I did not I did not ended the session, and there were only 2 students in the class. I am telling you everyone, maybe you will say that sir why sir is saying something like that. If you guys will not attend the classes, if you don't attend the classes, if you don't like this session, then maybe you will think that sir why are you saying like that? I will stop again. I will from the 4 months I have not taken I have not taught anywhere, right? I was waiting for joining an organization. Yeah, there is some financial need that I have to I have to work here or work in this kind of organizations. But if you guys come in the session and go like that I have not even stopped the session and just 2 students are there in the session. Next time if I find something like that, there may be many teachers in the YouTube, or there may be many teachers, many coaching, free coachings, but I'm going to leave this education system forever. Okay, so if you think that my sessions or my knowledge is something which is valuable for you and I should continue teaching, then it's my request that please follow these sessions. I just take 1 hour lecture for mechanical at 8 p.m. And if you guys don't come in the classes, then, or if you just leave the classes like that, just I am there in the session and everybody has left. If this is going to happen again, I'm telling you, you will never find me in any kind of platforms and I will be gone forever. Okay, that's it. I have to say. Consider the following statement for steam turbine. The ratio of actual enthalpy drop to isentropic enthalpy drop is known as mechanical efficiency. So this is wrong. This is called as nozzle efficiency. So if you think that I'm 1% beneficial for you guys for your exam and you need my lectures or you need that I should teach you, then don't do it again. I'm telling you. Hello Pushpin, good evening. Okay, I just want you 1 hour in one day. Okay, and that too, if it's not there, then what's the point? This is called nozzle efficiency, not mechanical efficiency. The ratio of enthalpy drop in the moving plate to the enthalpy drop in the stage is known as degree of reaction. Yes, that is correct. Ratio turbine is an example of reaction turbine, and as you can see from the level of the questions, these questions are not only for RRB JE. This is important for SSC JE CB2. So I don't have to remind again and again that those who have qualified CBD1 of SSC JE, these sessions are not only for RRB JE, they are also for SSC JE also. Curtis turbine is an example of impulse turbine. So this is wrong. This is correct. The answer will be option 2 and 4. 2 and 4, option A will be the right answer, because Curtis is an impulse turbine, but Ratio is also an impulse turbine, not reaction. Okay, so this is pressure compounded impulse turbine. Pressure compounded impulse turbine. Okay, and this is velocity compounded impulse turbine. Velocity compounded impulse turbine. All right. Next question. In a steam turbine with a steam flow rate of 1 kg per second, the inlet velocity of the steam of 100 meter per second, exit velocity of the steam of 150 meter per second, enthalpy at the inlet is 2900 and at the outlet is 1600. The power available from the turbine will be nearly. So for the steam turbine, the data of mass flow rate, velocity at the inlet or exit, everything is given. You have to find the power output. So whatever is given, just need to put it here. Okay, it is mass flow rate H1 plus V1 square by 2000 is equal to mass flow rate into H2 plus V2 square by 2000 plus power output. So you have to find the power output of the turbine. The power output of the turbine will be equal to mass flow rate of H1 minus H2 plus V1 square minus V2 square by 2000. Just put the values which are given. Mass flow rate is 1. This is 2900 minus 1600, that is 1300, plus 100 square minus 150 square by 2000. Solve it, you will get the right answer. Tell me what is the answer you are getting for the power output of the turbine. Okay. So you will get answer is 1293.75 kilowatt. Okay, option D. Option D will be the right answer. Clear? Is it clear to everyone? Next question. An ideal Otto cycle O and ideal diesel cycle D have the same maximum temperature and rejects equal amount of heat. Also, the working fluid enters at the same state before compression. One of the following statements are always true about their efficiencies. So we are having two cycles, one is Otto and other is diesel cycle, right? Otto is denoted by O and diesel denoted by D. They have same maximum temperature and reject equal amount of heat. What can you say about their efficiencies? Hi Pushpendra, welcome to the session. I can see that there are so many students live in this session. Thank you for following these sessions. I have for the mechanical there is only one class happening in a day, and if anyone is having this thought that we don't need to study technical at this point of time, we are preparing for RRB JE CBT1. So if you don't want these mechanical classes, I can ask my team to stop giving mechanical classes also, because students don't want to study technical right now. They only want to study non-technical. I can take other classes like paid courses. I will be taking other type of classes, but we'll stop giving you the paid technical classes. As you can see that there are only 3 students live in the session. Such a great number. I think I should stop the session today again. For the same maximum temperature and heat rejection, the efficiency of the diesel cycle is always greater than Otto cycle. So the right answer will be option C. I don't know how many of the students want the sessions. As you can see, I have to tell my team about this, that stop giving the technical classes, or I don't want to take technical classes. If you want to utilize me, you can utilize me for the paid courses, but not for the YouTube classes. I will stop taking the YouTube classes. I'm fed up of you guys. आप लोगों को समझाना पड़ता है कि पढ़ लो. क्या लगता है सितंबर अक्टूबर में नवंबर में जब पेपर होगा CBT1, then you will just clear CBT1 and then you will cry, sir, we want to study technical, provide technical classes. 2 महीने में कोई आपको जादू की गुट्टी पिला के आपको CBT2 तैयार कर देगा. Why don't you guys understand that आपको पहले से तैयार होना पड़ेगा. You have to be ready for the exam before the exam. Two closed gas turbines engines A and B operate on air standard Brayton cycle with efficiency eta A and eta B. If they operate between the same maximum and minimum temperature but with different pressure ratio of RPA and RPB, such that pressure ratio of the first turbine is greater than gas turbine is greater than second, then what can be said about the efficiency? Efficiency of the Brayton cycle depends on pressure ratio. It only depends on the pressure ratio. Does it depends on the maximum and minimum temperature? No. It depends on the pressure ratio. And if the pressure ratio, and how it depends, directly depends on the pressure ratio. If the pressure ratio of the first is more than pressure ratio of the second, then efficiency of the A will be greater than efficiency of B, Brayton cycle. So the answer will be option B for this question. Okay. The isentropic heat drop in the nozzle of an impulse turbine with a nozzle efficiency 0.9 and blade velocity ratio 0.5 and mean blade velocity of 150 meter per second, you have to find. How to solve this question? How you are going to solve this question? So blade velocity ratio, what is blade velocity ratio, my dear? Blade velocity ratio is given in this question, that is 0.5, and they have given the mean blade velocity. Mean blade velocity in this question is given as 150 meter per second. But they are asking you to find the isentropic heat drop in the nozzle. How you will find this? You know that what is nozzle efficiency? Nozzle efficiency is equal to actual enthalpy drop to the isentropic enthalpy drop. Is there any way we can find the isentropic enthalpy drop in the nozzle? Any relation for that? Is there any way we can find it? Okay. Nozzle efficiency is given. Isentropic heat drop you have to find. Blade velocity ratio is given in this question. Okay. How to solve this question? Tell me. See, you know that enthalpy drop is equal to change in kinetic energy. It is equal to change in kinetic energy. In the case of nozzle, it is equal to change in kinetic energy. So if the blade velocity ratio is given to you, with the help of blade velocity ratio, you can solve this question. Okay, try it. Everyone try to solve it. Yeah, Renault is getting 50 as the answer. Is it really 50? How you are getting 50, Renault? What have you used? What technique have you used to solve this question? All right. I hope you are using the same technique that I am thinking. See, first of all, you need to understand. Just a second. Yeah. This is the blade velocity, which is equal to 150 meter per second, and blade speed ratio of blade speed by jet velocity is equal to 0.5. So from here you will get jet velocity, which will be equal to u by 0.5, that is 300 meter per second. 300 meter per second will be equal to jet velocity from the nozzle. Now enthalpy drop, what is enthalpy drop? The actual enthalpy drop in the nozzle is equal to change in kinetic energy, which is equal to v square by 2. You will simply write v square, that is 300 square by 2. Okay, so you will get the enthalpy drop actual, and isentropic enthalpy drop will be equal to actual enthalpy drop, that is 300 square by 2 divided by nozzle efficiency, which is 0.9. You will get the right answer. Okay, getting this, everyone? Have you understood this concept or not? So you will get 50. This will be 50 kilojoule per kg. So the answer will be option A. I hope all of you are getting this. Understood? Because enthalpy drop is equal to, yes, very good. From the given data, firstly you will get the value of actual enthalpy drop, which is equal to change in kinetic energy, which is equal to jet velocity, that is equal to half of jet velocity square. So you will get this actual enthalpy drop. And if you know the actual enthalpy drop, you know nozzle efficiency, you will get isentropic enthalpy drop. Clear? Next question, in a steam turbine with steam flow rate of, I think this question is repeated. Next question, use of maximum pressure ratio corresponding to maximum to minimum cycle temperature ratio in case of Joule cycle gives which of the following? Please read the question carefully. This is engineering services previous year question. Yeah, here one more thing you have to do, you have to divide by 1000. Then only you will get the answer in kilojoule per kg. So divide by 1000. Okay. Then only you will get the enthalpy drop in kilojoule per kg. Yes. Use of maximum pressure ratio corresponding to maximum to minimum cycle temperature in case of Joule cycle gives which of the following? So basically what they are saying in this question, that we are having Joule cycle, which is also known as Brayton cycle, and this Brayton cycle is working between minimum and maximum temperatures. Okay, it is working between minimum and maximum temperature. The minimum temperature is T1, the maximum temperature is T3, Okay, this is your Brayton cycle or Joule cycle. So if corresponding to maximum pressure ratio, at when the pressure ratio becomes maximum in the Brayton cycle, then the net work becomes 0 and the efficiency becomes maximum, which is equal to 1 minus minimum temperature divided by maximum temperature. So basically the maximum efficiency but very less work output. You will get efficiency maximum but less work output when the maximum pressure ratio will be there. Okay, clear? A thermometer in the vapor compression system is installed in the main line close to the compressor. In the case of vapor compression system, a thermometer is kept in the main line close to the compressor. Okay, so again if I draw the vapor compression system components: condenser, throttling device, then evaporator, and just after the evaporator we have a component that is compressor. Okay, compressor. Now after the before compressor and after the evaporator we keep a thermometer, and that thermometer helps in what? Yes, tell me. So we keep a sensing bulb here. We keep a sensing bulb. Sensing bulb basically acts as a thermometer only that will tell you degree of superheat. Okay. So why we use a thermometer here? It helps the operator to adjust compressor for greatest efficiency. As temperature indicates whether liquid or vapor is going to compressor. It helps in calculating coefficient of performance as the performance of other units can be controlled. So the right answer is basically it is used to sense degree of superheat, and degree of superheat is somewhat related to cooling also. Okay, so it's not that what should be the right answer for this question based on the options. Why we need this thermometer? What is the main purpose of using this thermometer in the case of vapor compression system? So it's basically it helps the operator to adjust the compressor for greatest efficiency. Okay, so the right answer is option A for this question. In the vapor compression system, see, as per the option we have to mark this answer. Although this thermometer is not just helping the compressor, it also helping the evaporator. It will ask the throttling device. It will ask the throttling. Now here the throttling is not used. We use a thermostatic expansion valve. It will ask this valve to deliver the liquid refrigerant into the evaporator to maintain constant degree of superheat. But as per the option, the right answer will be option A. It helps the operator to adjust the compressor for greatest efficiency or COP. Okay. Next, experimental measurement on a refrigeration system indicate that rate of heat extraction by the evaporator, rate of heat rejection in the condenser, and rate of heat rejection by the compressor body to the environment are given. The power input to operate the system is. So in this question, what components are given? Evaporator, condenser, and compressor. Okay, so you know it very well that for a refrigeration system, what we know for refrigeration system, it works in a cycle, right? It works in a cycle, and for a cycle net heat is equal to net work. Net heat will be heat rejected minus heat supplied is equal to work. Okay, what is the heat rejected? Where is the heat rejected? Evaporator heat is supplied, heat rejection the condenser heat, and these are two heat rejection. So heat rejection will be 90 plus 5. Where is the heat supplied? In the evaporator, which is 70. that will be work. Okay, so 95 minus 70, that will be work. Clear? That will be 25. So work will come out to be 25 kilowatt. Clear? Is it clear to everyone? That is a simple technique we know. Okay, because heat rejection, where is the heat getting rejected? In the compressor and in the case of condenser. So heat rejection is total this. Where is the heat supplied? In the evaporator. Minus heat supplied in the evaporator will give you the work input. Okay, so this is the answer. Next question. Otto cycle efficiency is higher than diesel cycle efficiency for same compression ratio and heat input, because in the Otto cycle we know that this we have studied so many times, that for same compression ratio, yes, Otto cycle efficiency is more than the diesel cycle efficiency. But what is the reason? For same compression ratio and heat input, the Otto cycle efficiency is more than diesel cycle efficiency. But what's the reason? Reason is efficiency depends on heat rejected and heat supplied. If the heat input is same, then the cycle which will be having less heat rejection will be having more efficiency. Because we know the result that for same compression ratio, Otto cycle has more efficiency. That means we can say that heat rejection in the Otto cycle will be lesser than heat rejection in the diesel. That is why it is having more efficiency. So answer is heat rejection is lower in the Otto cycle. That's the reason. Okay. A 4 kilowatt 20 liter water heater is switched on for 10 minutes. The heat capacity for the water is 4 kilojoule per kg Kelvin. Assuming all the electrical energy has gone into heating the water, the increase of the water. So all electrical energy, if all electrical energy goes into heating of the water, that means it is increasing the increasing the internal energy of the water, right? It is increasing the internal energy. So electrical energy is how much? 4 kilowatt. Okay, so 4 kilowatt is equal to increasing the internal energy, that is equal to mc delta T. Okay, is it clear? You have to find this delta T. In this question they have given the value of specific heat is given 4 is equal to mass into 4 into delta T. But you don't know the value of mass. How you will find the value of mass? They have given the volume, they have given the time 10 minutes. One more thing is they have given the electrical energy in kilowatt. So the heater was switched on for 10 minutes. So what we will do here, we will convert this kilowatt into kilojoule. How? 4 kilojoule per second into 10 minutes, and it is minute. So you have, in order to convert second, it will be 60 seconds. Okay, that will be mass into Cp, which is 4 into delta T. Clear? Now, next thing what we have to do, this second and second will get cancelled out. Next thing we have to do is mass. Now, density is equal to mass per unit volume. We all know that. So, mass of the water will be equal to density of the water, which is 1000 into volume, which is 20 liter. Liter is 10 power minus 3 meter cube. So, you will simply get 20 kg. The mass will be 20 kg. Just put the value of mass as 20 into 4 into delta T. You will get the answer. Tell me what is the answer you are getting? Yes. So you will get delta T is equal to 30 degrees Celsius. Clear? I hope everyone is getting the same value of delta T increase in temperature. Next question. A gas expands from pressure P1 to pressure P2. Is Gautam there in the session? You can see this is how the question will look bold. If the question you were asking many times, sir, please make the question bold. Same question asked 2 days ago in NPCIL. Okay. So if one more thing I want to ask everyone, if you are having any previous year papers, if you want to have, you think that those questions are really nice, you want to have the solution of those questions, You can also send your papers to me in my Telegram, okay? And I will be giving the solution to those questions. If the process of expansion is isothermal, the volume at the end of expansion is this much. If the process of expansion is adiabatic, the volume at the end of the expansion will be closer to. Very, So here they are saying on a pressure volume diagram, just see the question, what is being given. In the question it is mentioned that there are two types of expansion going. One is isothermal expansion, constant temperature expansion, and one is adiabatic expansion. All right. So just let me know that in which expansion. So they are asking, okay, they are saying that volume at the end of expansion, if it is isothermal expansion, it is equal to V2 is 0.55 meter cube. If it is isothermal expansion. Now, what will be the volume if it is adiabatic expansion? What will be the volume if it is adiabatic expansion? Clear? So tell me, what will be the volume? So if you see this, for isothermal expansion, you know it very well that the process is starting from point number 1. Isothermal expansion P1 V1 is equal to P2 V2 is the equation, right? Just see how I am solving this question. Now P1 is equal to P1 into V1, P2 is equal to P1 by 10 into V2. V2 is how much? 0.55 for isothermal expansion. So from here what you get? You get V1. V1 will be equal to 0.055 meter cube. This will be value of V1. So V1 you get from here. V1 will be equal to 0.055. Okay. Now for adiabatic process, P1 V1 power gamma is equal to P2 V2 power gamma, right? So what you can get from here, P1 by P2 will be P1 by P2 power 1 by gamma into V1 is equal to V2. Okay. Ramjivan, we can discuss that in the Telegram also, that how you can prepare for it. Okay. So you can personally connect with me. So this will be 10 की power 1 divided by 1.4. 7 into. So you will get, okay, I think I am doing the right calculation here. 10 gamma is 1.4 now. Just a minute. So you will get V2 as 0.282 meter cube. But here you are not getting any value like that. So we will get option A as the answer. The closer value will be 0.45. Okay. Obviously it will be lesser than the value of volume that you get in the case of isothermal, because the value will be closer to which value, because they are not asking the exact value, that the value will be closer to 0.4, because 0.28 will be closer to 0.4, not any other values. And obviously it will not be more than 0.55, because more expansion you obtain in the case of isothermal expansion as compared to, just see the relation also. Here the relation between the volume and pressure is like this, but here it is in terms of gamma. Okay. So if it is 1 by gamma ratio of the pressure, obviously the volume will be lesser than 0.55, what you obtain in the case of isothermal expansion. So lesser than 0.5 will be only one option, option A. Okay. So this is a little bit, tricky question. Assertion: axial flow air compression needs many stages to develop high pressure ratio. Axial flow compression needs many stages. What kind of stages? Actually, the pressure ratio of axial flow compressor is 1.2 to 1.4 for axial flow. So the pressure ratio is very less. So multi-staging is required. Multi-staging is required, actually required in the case of axial flow compression. In axial flow compressor, to get axial flow, to get high pressure, ratio. Okay, so the first option is correct. The amount of turning of the air flow in blade row is limited by the occurrence of separation, a phenomena caused by adverse pressure gradient. Just read the question carefully. Amount of turning of the airflow in the blade row is limited by the occurrence of separation. Yes, separation is a phenomena which happens because of adverse pressure gradient. So this statement is correct. But if this statement has any role with the first statement here? No. So both are not related. Both are not related to each other. So the answer will be option B. A and R both are true. Both are individually true, but the reason given here is not a correct explanation to the assertion. Okay. What is the correct sequence in the increasing order of air handling or compressing machine based on the pressure ratio? Because separation, what separation they are asking? Boundary layer separation. The boundary layer separation problem happens because of adverse pressure gradient. When the pressure gradient, what is adverse pressure gradient? Pressure gradient becomes positive. Pressure gradient becomes positive. Okay. So yes, that is the reason, but that is nothing to do with the assertion. What is the correct sequence in the increasing order of handling air handling compressing machine on the pressure ratio? So based on the pressure ratio, you know that which will be giving you more discharge based on the pressure ratio. So if we have to find the based on the pressure ratio, then pressure ratio will be more in the case of increasing order. Increasing order will be a fan followed by blower, then centrifugal compressor, then receiving compressor. If they are asking discharge of the air in terms of discharge, okay, then discharge will be maximum for centrifugal compressor. But based on the option that is given here, reciprocating in the end, obviously they are asking about the pressure ratio. Based on the pressure ratio they are asking. So the answer will be axial flow fan, then air blower, then centrifugal compression, then reciprocating compression. Because if in the end, if they are giving reciprocating compression, obviously they are asking on the basis of pressure ratio. So based on the pressure ratio, you know that reciprocating compressor has highest pressure ratio. Okay. Because what else they are asking in the terms of increasing order? Increasing means smallest to largest. So largest, because in the end in all the options they have given reciprocating. So they are asking pressure ratio. Pressure ratio highest is reciprocating, but before reciprocating it is centrifugal, then blower, then axial flow fan. The answer will be option D. Okay. Axial flow fan or axial flow or normally a fan has a lower pressure ratio, then blower has more pressure ratio. Centrifugal compressor has a pressure ratio of 3 to 4. This has pressure ratio of 1000. This has pressure ratio of 2.3 up to 2.3, and this has pressure ratio up to 1. Next, for a multi-stage reciprocating compressor, which of the following statements are correct? Multi-staging in reciprocating compressor, which of the following statements are correct? It decreases the volumetric efficiency, the work of compression is reduced, the high pressure cylinder is smaller in size. What is the purpose of multi-staging in compressor? Multi-staging in compressor will obviously increase the volumetric efficiency. Volumetric efficiency will increase. Okay, volumetric efficiency increases by multi-staging. Efficiency will increase, the compression work will reduce, and high pressure cylinder small in size, yes. These all statements are absolutely correct. As the compression, see, the first cylinder, my dear, after the first cylinder we have intercooler, and after the intercooler we have the second cylinder. The second cylinder is smaller in size. This is the second cylinder. Cylinder means the reciprocating compressor cylinder. The first cylinder is always larger in size, large size. Why? Because this is the cylinder where the air first enters. The air enters in this, air suction takes place here. And after suction, the volume is reduced. Volume is reduced and pressure is increased. So if the volume is reduced, so less volume air goes into this compressor. So that is why this compressor is small in size. Small in size. The high pressure is small in size and low pressure is, it decreases the volumetric efficiency. The first statement is not correct. So the right answer will be option B, 2 and 3. Okay, this is incorrect. Next question. Water flows between two parallel fixed plates 60 mm apart. Velocity distribution for the flow is given by the relation 120.05 y minus y square. So velocity is given as 120.05 y minus y square. Dynamic viscosity is also given, magnitude of shear stress acting on the bottom plate. So basically the water is flowing between two parallel fixed plates, and these two parallel fixed plates between which water is flowing are having distance of 60 mm between them. Okay, so they are 60 mm apart. 60 mm apart. All right. So the distance y is given here. Shear stress, you know, it is equal to mu du by dy, right? So you can just find the du by dy first. It will be equal to, differentiate it. It will be equal to how much? 120 into 0.05 minus 2y. Okay, 2y. Y is equal to what? How much is the y? Y is equal to 60 mm is equal to 0.06 meter. So just put du by dy is equal to 120.05 minus 2 into 0.06. You will get the value of du by dy. Shear stress is given, just solve it and tell me the answer. Of course, there is some mistake here. I think what's the mistake? 60 mm apart, the velocity du by dy. $120. So no matter, it will be 6y minus 120y square. Ultimately, when you solve this, if you differentiate it du by dy, it will be 6 minus 1 minus 240 into y. Ultimately, it will be 6 minus 240 into 0.06. How much? Oh, this is coming out to be minus 8.4. du by dy at y is equal to 0.06 is minus 8.4. Multiply this 1.3 into 10 power minus 3 into minus 8.4. How it is coming out to be minus? There's some mistake here, I think, in the data. That's why the answer is in minus. So it is coming out to be 0.01092. 0.010. No options are there. Yeah. Are you all getting the same value? Question nahi dikh raha clear. Yeah, I think there is a mistake in the question. There is some mistake in the equation of velocity. That is why the value of velocity gradient is coming out to be negative. How is it possible? So there is some mistake in the question. I think in this equation there is some mistake. There is some mistake here. That's why the answer is not coming correct. I have to see this. I have to check this once, and I will let you know. Okay. Consider the following velocity profile. See this question. U by u infinity is equal to minus 2 y by delta minus y by delta whole square. So this is the velocity profile given minus 2 y by delta minus y by delta square. Clear? Determine whether the flow is not separating, flow has separated, flow is on the verge of separation, none of the above. See the first statement, flow is not separating. When the flow is not separating, when velocity gradient du by dy at y is equal to 0 is positive. Flow has separated. When it is separated, when velocity gradient du by dy at y is equal to 0 is less than 0. Flow is on the verge of separation when du by dy at y is equal to 0 is equal to 0. So what we need to find is du by dy. So u will be equal to u infinity minus 2 y by delta minus y square by delta square. You just need to differentiate du by dy and then put y is equal to 0. What you will get? Yes, you will get u infinity minus 2 by delta and minus 2y by y square, delta square. If you put y is equal to 0, what you will get? This will get 0, you will get minus 2 u infinity by delta. You are getting this value as negative, less than 0. If it is negative, it is flow has separated. Okay? If the velocity gradient is negative, the flow has separated. Clear? Is it clear to everyone? Understood? So this kind of concept can also be asked in the exam from boundary layer separation, that they can ask you, okay, whether the flow is separated or not separated. All right. Pressure drop of flowing through a pipe. Density is 1000 kg per meter cube. Density is given to you 1000 kg per meter cube. Between 2 points is measured by using a vertical U2 manometer. Manometer uses a liquid with density of 2000. The difference in the height of the manometric fluid is equal to 20 centimeter. The pressure drop between the 2 points is. So you know that the pressure drop is being asked in the Newton per meter square. So firstly you can find the value of H. H will be equal to X okay, density, manometric fluid density of the manometric fluid divided by density of the fluid in the pipe minus 1. From here you will get the value of H. Tell me the value of what H you are getting. If you get the value of H, you can find the value of pressure drop between the 2 points. I think this is the same. This approach will be used here or any other approach. The pressure drop is given. So you will apply the concept of manometer. Yeah. Okay. All right. So this is H, right? You will get X as 0.2 into 2000 divided by 1000 minus 1, that is, you will get this value as 0.2. Okay. You have got the value of H. Now you have to find the pressure drop here. And H is equal to X. Yeah, you can say H is equal to X. Now pressure drop, you know that P1 minus P2 by rho G is equal to H. So you will get pressure drop as equal to rho GH. You have to find the pressure drop in the pipe. The pipe is having density of 1000, so it will be 1000 into 9.81 into 0.2. Simple. Solve this, and this is also the last question. I can see again the students leaving the session. You guys don't listen, I guess. I will not take any session from the next week. I'm telling you. This will be the last week I'm taking the YouTube classes. Now I have decided. You guys don't deserve these classes. No, not from, there will be classes from other faculty, but not from me. I think you had enough of concept of thermodynamics, applied thermodynamics in FM. Now I think you don't need these concepts. A turbine, last question for today's session. A turbine develops for 8000 kilowatt of power. When running at 100 RPM, the head on the turbine is 30 meter. If the head is reduced to 18 meter, determine the power developed by turbine. Is there any relation between the power and the head of the turbine? For the turbine, the power, you know the relation P, unit power is equal to P by H power 3 by 2. So you will be using this relation. Why flowing fluid density? I'm not able to understand this question. Because you have to find the pressure drop between the 2 points. Where the manometer is like. See, pressure drop you have to find the pipe, right? At the 2 section of the pipe by the differential manometer. So that's why we have taken the density of the fluid in the pipe, not the manometric fluid. Manometric fluid is the role of the manometric fluid is that to create this manometric deflection of 20 centimeter. But when you have to find the pressure difference, we'll be using this density of the fluid in the pipe. Okay, Sagar? So you will simply apply the relation P2 by P1 is equal to H2 by H1 power 3 by 2. So use the relation P2 will be equal to P1 is 8000, H2 is equal to how much? 18 by 30 power 3 by 2. Simply use this relation, you will get the answer. Tell me what is the value? Yeah, it will be 3718.06. So the answer will be option A. Okay. I think the units are wrong here. Kilowatt, 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 kilowatt. That's all for today. Rest of the question will be taken in the next session. Thank you so much everyone for joining me for this session. And I'll see you in the next session. Thank you so much. I'll see you tomorrow. I'm going to see you tomorrow at 8 p.m. Okay. Thank you everyone. See you tomorrow at 8 p.m. Thank you. Have a nice day. So if you like the session, then do not forget to hit the like button and share the session. I will see you tomorrow at 8 p.m. at the same time, that is 8 p.m. Thank you so much. Take care. Have a nice day.